Okay, so we're looking at the notes for section 1.5. This is the second part of this. I want to go through the methods that we can use to evaluate limits. We have a little space over here to the side, and let's just kind of write down some things that can happen with limits. Anytime we're trying to do any limit problem, the first thing that we should always try to do is just plug in the value. When we plug in the value, some other things might happen. One thing that might happen is we just get a numerical answer. We'll just say a number. If we get just a real number answer, then we know we're finished. And when I say a number, I just mean a number like 2, 3, 1/2, 5/8. Anything that's a real number and that does not involve a zero in the denominator. So we will, if we get a number, we're finished as long as no zero in denominator. So if I get an answer of 0, I am finished. But if I get an answer of 1/0, I'm not finished. So the other thing that can happen is we do get a 0 in the denominator, like we get 0/0. If we get 0/0, what do we have to do? More work, right? So we have to do more work. Some of the things that we might want to do for this is we might want to try factoring. So we might want to factor and cancel. Or we might even just want to look at the graphing calculator. So those are a couple of things we can do. The other thing that might happen when we plug in a value is that we might get a constant over 0. Now when that happens, we've got to think about what to do in that case. We know that if we get a constant over 0, the general limit, we'll just call that general L, does not exist. So anytime we get a constant over 0, that general limit will not exist. However, if it's a one-sided limit, then we have to test values close to the vertical asymptote. And there's only two answers we can get as we approach a vertical asymptote. What are the only two possibilities? Right. So we will either get infinity or negative infinity for the answer. And that's how we do limits. Always start off by plugging in the value. No matter what, even whether it's a one-sided limit or a general limit, that's what you always do first. And then you'll go in one of these directions. Just kind of follow the flow. So let's look at example 1 then. What's the first thing that we always try to do? Plug in the value. So we will just try to plug it in. If I plug in 1, I'm going to get 3/0. So now looking at our flow chart, we got a constant over 0. So we know the general limit does not exist. But this is a one-sided limit. We're trying to find it from the positive side. So when we have a one-sided limit, we have to test values close to that vertical asymptote. There's a vertical asymptote there. So the number that we have to check that's just a little bit bigger than 1 is going to be 1.001. So I'm going to plug that in. 2 plus 1.001 over 1 minus 1.001. We get 3.001 over negative 0.001. Well, if I multiply the bottom and the top by 1,000, I'm going to get 3,001, and this is just going to become negative 1. So what does that mean then? I know the answer has to be one of two things. So if I'm getting a huge number divided by negative 1, what does the answer have to be then? Negative infinity. Good. If I wasn't sure that I did that correctly, and I'm taking a quiz and I have a graphing calculator in front of me, I should look at that and see if it is correct. All right, let's do number 2 now. First thing we do is we plug in 0. Doesn't matter that it's a one-sided limit. 0 squared is 0 minus 1 over 0. Well, once again, we got a constant over 0 as part of our answer. We have a one-sided limit, so we're going to have to test something close to that. So what I'm going to test is something a little bit smaller than 0. What's that going to be, Peter?
Negative 0.9.
That would actually be close to negative 1.
Negative 0.00.
There you go. That's okay. So we're going to have to plug that in. So we don't have to plug that in here though, because this wasn't the problem. This was just 0. We don't need to worry about that. So we have 0 minus, and then I'm going to have 1 over negative 0.001. Well, what it would have been saying? A constant divided by a very small number is going to be what? That's negative infinity. So I now have 0 minus negative infinity. And so what's it going to be then? Just infinity. Okay? All right, let's just check that one on the graphing calculator. When we do something that seems, a little bit tricky, especially with the minus, the negative, just want to double check it. So we can go to y equals, put in x squared minus 1 over x, do a zoom 6, and here's the way the function looks. So as we approach 0 from the negative side, that's right there. It's kind of hard to see it from the graph, guys, but watch this. If I hit trace, and I want to get really, really close to 0, but I want to be on the negative side of it. So I'm kind of tracing it. Okay, I can't get in there close enough. So I'm going to just check something that's really close to 0 from the negative side, that negative 0.001. And see what it's telling me? That the function is going up to infinity. So I can double check that, and I can see that that is correct. All right, let's try number 3 now. This one's a little tricky. We plug in pi, we get pi in the numerator, sine of pi. Well, maybe we need our unit circle to figure this out. Here's 0, this point's going to be 1, 0, this point's 0, 1, this point's negative 1, 0, this point's 0, negative 1. So right here is 0, pi over 2, pi. So what is the sine of pi going to be then? 0. So we have a constant over 0. So that means there has to be a vertical asymptote, because we got a 0 in the denominator. Now I have to approach pi from the negative side. Okay? So think about this. Something a little bit less than pi. If pi is 3.14, I could theoretically test 3.13, I guess. But I don't know the sign of 3.13. So what's something that's less than pi that I do know the sign of? If I were doing trig problems, I would know the sign right here. What's that angle that's right there, a little bit before we get to pi? Pi over 3? 2 pi over 3? 2 pi over 3 would actually be up there. It's a little bit further away. 5 pi over 6, right? So that's what I'm going to plug in. So I'm going to have, remember, what does our answer have to be here? One of two things. What? Positive or negative infinity. So I'm going to plug in 5 pi over 6 for x. So 5 pi over 6 over, do you know the sign of 5 pi over 6? You should know that, guys. 1/2. I know my answer has to be positive or negative. Infinity. So what does the answer have to be based on this result? Positive infinity, right? I have a positive over a positive, so the answer has to be positive infinity. See, look at this graph. X divided by the sine of x. I have to do a zoom trig because it's a trig function. Here's the way the function looks. So to support what I think it is, I do second calculated value. I want to get really close to pi. This time I am going to have the calculator check. 3.14 is even less than pi, isn't it? Because pi is 3.14159265535. So now I'm going to push enter, and I get this answer. So does that support the fact that the answer should be infinity? Yes, it does. Alright, next problem. I try plugging in 1. I get 0 over 0. Are we approaching a vertical asymptote when we get 0 over 0? No, we are not, are we? So we are not going to plug in a number like 0.999. Guys, think about this again, because here's what people do. They get to a problem, they get 0 to 0, and now they plug in 0.999, and everything falls apart, and they're like, I have no idea what's going on. That is not what this problem is all about. We're approaching a hole in the graph here. There's no vertical asymptote. This should have a numerical answer. What do we do to solve it? What do we do, Michael? Synthetic division is a great choice. So what I do is, I think of what's going to make this equal 0, and it's 1. My coefficient of x to the third is 1. My coefficient of x squared is 0. My coefficient of x is 0. Then I write my constant. I'm going to bring this down. 1 times 1 is 1. I add. There we go. So this is what I get when I divide that out. So now my problem is going to be the limit as x approaches 1 from the negative side of x squared plus x plus 1. My denominator's gone because I divided by it. And now, am I plugging in 1 or negative 1? 1. Guys, this is just saying from the negative side. I just want to plug in 1. I don't care about that little negative there. So 1 squared is 1 plus 1 plus 1, and that's going to be 3. Now, just so you can understand why it turned out this way, let's look at this on the calculator. I'm going to type it in. We've got x to the third minus 1 divided by x minus 1. We're going to do a zoom standard, and here's the way the function looks. I want to plug in 1, so I go to second, calculate a value when x is 1. Nothing there. Well, let's check a value that's really close to 1 from the negative side, like 0.99999. And look what it gives me. Does that support the fact that the answer is 3? Now, if you guys were on the test and you gave me 2.9999997, not correct. That is not the answer for the limit. The answer to the limit is 3. It's the integer that we are approaching. All right, let's look at number 5, discontinuities. We've talked about discontinuities. We get a hole in the graph if the factor will cancel with the numerator. We get a vertical asymptote if it does not. So factoring this, I have 4 terms. I have to divide it up. 2 terms here, 2 terms here. These 2 terms I can factor out in x squared, and I'm left with x minus 3. For these 2 terms, I can't factor out anything, so I just have to take out a 1, and I'm left with x minus 3. So now I have 2 new terms. This is 1 term. Terms are separated by pluses and minuses. Here's another term. What do these 2 terms now have in common? X minus 3, so I'm going to factor out an x minus 3. If I factor an x minus 3 out of this term, I'm left with x squared. If I factor an x minus 3 out of this term, I'm left with plus 1. So here's my numerator, here's my denominator. Does anything cancel? X squared plus 1 does, doesn't it? So there should be a hole in the graph at whatever would make x squared plus 1 equal 0. But if I solve this, watch what I get. You guys remember doing that? Nice news for us is that we don't deal with imaginary numbers or complex numbers at all in calculus. So there's no real number that's going to make that equal 0. So therefore there's no hole in the graph. This will actually be a continuous graph, bless you. But what is this going to cause us to have? Vertical asymptote. So we have a vertical asymptote at x equals 3, and that's the only discontinuity this function has. If we wanted to double check that, we could look at the graph. Okay, the rest of these are kind of review, but let's do them together just to make sure everybody remembers what to do. Example 6. Determine the value of c so that f of x is continuous on the entire function. Who knows what to do for this kind of a function to make it continuous? What do we do? Nick, do you know? Okay, so we're going to plug 3 in here. What would you get? So that means that if I plug 3 in here, I also have to get 1. So look at what this function is. The second part of my function is y equals cx plus 7. That's the second part of my function. And I know that if I plug in 3, I've got to get a 1 in order for them to meet and be continuous, one entire continuous function. So what do we do now? Lizzie? Good. So I'm going to get negative 6 equals 3c, and so c equals negative 2. So that's going to be what the value is there that's going to make it a continuous function. It's going to go from one line to another line, and it's going to be continuous. It's going to meet right there in the middle at 3. All right, what about example 7? Find the value of c guaranteed by the intermediate value theorem. Who remembers what to do on this? Haley, do you know? Right. This is the y value. This is saying if we plug in c for x, f of c has to be 4. So here's f of c, that's 4. Anywhere I see an x, I'm going to replace it with a c. Here's our function. To solve a quadratic, we get it set equal to 0. So now I'd have to factor that. I get c equals negative 3 and 2. So Spencer, does that mean my answers are negative 3 and 2?
No, the negative 3.
Right. My interval says that c must be in between 0 and 3. This is not in between 0 and 3. So therefore, the only answer is c equals 2. The last one. Find the limit as x approaches 0 from the negative side. First, we try plugging it in. We plug in 0, we get 0 over 0. We have to do more work. So what I'm going to have to do on this one, I can't factor it. I can't do anything else except graph it. I have to know what this graph looks like. What is it? Yep, it's going to be a straight line until we get to 0, and then it turns into this. That's just something we just need to know that function. It's one that comes up over and over. And so now they're asking us for the limit as x approaches 0 from the negative side. What does that answer, you guys? Everybody? Negative 1. Okay? All right. So that's it for now.